Welcome to the lecture series of signal system. In the previous few lectures, we have seen the trigonometric form of the Fourier series. We have seen the exponential form of the Fourier series. Also, we have seen how we can extract the coefficients of trigonometric Fourier series from the exponential Fourier series and coefficients of the exponential Fourier series from the trigonometric Fourier series. This is what we have seen in the previous few lectures, and we have gone through some examples also. Now in this lecture we will discuss some useful properties of the Fourier series, in which in this context the first property is linearity of the Fourier series. Linearity means if there is a signal x1t produces the Fourier coefficient Cn, it means that, as we know, the formula to determine the Fourier coefficient in the exponential Fourier series is 1 upon t integration over one time period xt e power minus j n omega naught t dt. This is the formula to calculate the coefficient Cn of exponential Fourier series. If Cn is the Fourier coefficient for the signal x1t, then Cn can be written as 1 upon t x1t e power minus jn omega naught t dt, and x2t, if dn is the coefficient for the Fourier series, exponential Fourier series of x2t, then dn can be written as this 1 upon t, and in place of x1t we will put here x2t e power minus jn omega naught t dt. So all these are expressed here as x1t produces Cn, x2t produces dn, and then Fourier series of ax1t plus bx2t will be equal to, in place of xt we will put ax1t plus bx2t. Now this integration can be distributed over both the signals x1t and x2t, and this will become 1 upon t ax1t e power minus jn omega naught t, and the second term will become 1 upon t integration over one time period bx2t e power minus jn omega naught t. Now here this term, if we will put these constants outside of the integration, then 1 upon t integration of x1t e power minus jn omega naught t dt means this term is Cn, and multiplied by this constant a, plus if we will put this constant b outside of the integration, then remaining part of the integration will become 1 upon t integration of x2t e power minus jn omega naught t dt, means this term will become dn. It means that if x1t produces Cn and x2t produces dn, then ax1t plus bx2t will produce a into Cn plus b into dn. This is what linearity says. If x1t produces Cn x2t produces dn, then ax1t plus bx2t will produce acn plus b times dn. Now the second property of the Fourier series given here is the shifting of the signal, time shifting property of the Fourier series. This property says that if a signal, any general signal, periodic signal xt produces the Fourier coefficient Cn, and we will shift this signal by t naught unit, then the coefficient Cn will be multiplied by e power minus jn omega naught t naught. This has importance that if the signal is shifted by t naught, then here this term will be t naught will be on the power of e. Also, if there is a signal, look into this signal xt is producing Cn, then if xt is shifted by t naught unit, if xt is shifted by t naught unit, then we does not have to calculate this Cn again, just we will multiply the Cn by a term e power minus jn omega naught into t naught. That's it. If here is a plus xt plus t naught, then we will multiply the Cn by e power plus jn omega naught t naught. Now we will look into the proof. Signal xt can be represented in the form of exponential Fourier series as xt is equal to n is from minus infinite to plus infinite Cn e power plus jn omega naught t. Now then how xt minus t naught can be written? It can be written as, in place of t, in this relation we will replace this t by t minus t naught, then this will become xt minus t naught equal to n is from minus infinite to infinite Cn e power jn omega naught t minus t naught, and this t minus t naught can be written as Cn, this term can be written as e power jn omega naught t into e power j minus jn omega naught t naught. This can be written in this form. Now this will be included with the Cn, and this will become Cn into e power minus jn omega naught t naught into e power jn omega naught t. Sorry, this is t here, this is not t naught, this is t. So if we compare with the equation, with the exponential formula of exponential Fourier series, we will get here, in place of Cn, this is Cn into e power minus jn omega naught t naught. It means that if Fourier coefficient for the signal xt is known, then the coefficient for the signal x of t minus t naught will be e power minus jn omega naught T naught into Cn. Now move to the next property, which says that the time reversal property means if the coefficient for xt is Cn, then the Fourier coefficient for x of minus t will be c subscript minus n. How we can prove this? By the definition of Fourier series, we can write signal xt as summation from minus infinite to plus infinite Cn e power j n omega naught t. Now if this t here is replaced by minus t, then this t will also be replaced by minus t. Now how it will look like? X of minus t will be equal to summation from minus infinite to plus infinite Cn e power minus j n omega naught t, because this t is replaced by minus t. That's why this minus sign is here. Now substitute n is equal to minus p in this relation. So when we will put n equal to minus p, the limit is from n is equal to minus infinite to n is equal to plus infinite. When we will put minus p in place of n, means this will become minus p, this will also become minus p, then p limit will become p from in plus infinite to minus infinite, and this will become Cn e power plus, this Cn will become c minus p, because in place of n we are putting minus p, then this term will become c subscript minus p e power j p omega naught into t. Now if we will look here, this will become p from infinite to minus infinite c subscript minus p e power j omega naught p into t. If here limit is applied on the p, now this p can be replaced by n, this p can be replaced by n. This is only change of variable, this does not affect the relation anywhere. We can write n in place of p. So if we compare with the formula of exponential Fourier series, here this is in place of Cn, this is c subscript minus n. Then it means that if a signal xt produces Fourier coefficient Cn, then x of minus t will produce c subscript minus n. This is what the time reversal property says. Another property here, the time scaling property. Time scaling property means if a signal xt produces coefficient Cn, then x of alpha t will also produce the coefficient Cn, but omega naught will be replaced by alpha times omega naught. This is what time scaling property says. Look here, the proof. From the definition of exponential Fourier series, the general signal xt can be written in the form of exponentials as xt is equal to n is from minus infinite to plus infinite Cn e power j n omega naught t. Now if we will replace t by alpha t, then this will become sigma from minus infinite to plus infinite Cn e power j n in place of t I will write alpha into t, and this will become e power j n alpha omega naught into t. By comparison, we can say that if xt produces the coefficient cn, then x of alpha t will also produce the coefficient cn, but the term omega naught, the fundamental frequency omega naught, will be multiplied the same constant alpha. These are some basic properties of the Fourier series. In the next coming lectures, we will discuss different time differentiation, time integration, convolution, multiplication, all these important properties. So this is all for this lecture. Thank you.